All right. So today we're going to talk about the graphs of logarithm functions. So we're going to do the same things we did with survival functions. And when we do that, we're going to talk about the function is log base A of x. And we say A is a number and it's the base. And we've already said that x is the argument. Okay. This graph basically looks like this. It comes right up against the x-axis. It crosses at 1 and then goes over like this. So its x-intercept is right here at 1. It has no y-intercepts. Its domain, it starts at 0 because what happens is it's and it goes on to infinity. So it goes from 0 to infinity. And it doesn't include 0 because the x-axis is an asymptote. So the graph runs right up along I said the x-axis, I meant the y-axis. The y-axis is an asymptote, just like the x-axis is an asymptote for the exponential function, because remember, these are inverses of each other. Okay, the y-axis is an asymptote. The range of this function, well, it goes from negative, because it goes from negative infinity, goes down to negative infinity and up to negative infinity. So negative infinity to infinity. Remember, this is left to right and down to up. It increases everywhere on its domain. So it increases from 0 to infinity. It decreases never. So it has no max and it has no min. Its end behavior as x goes to infinity, as x goes this way, then y goes to infinity. As x goes to negative infinity, well, it doesn't go to negative infinity, so this doesn't apply. Okay, so this is the thing that the logarithm function, this is the basic logarithm function. Now, when we're talking about logarithm functions, this graph can be flipped and turned and done all the kinds of things, and it applies with all of the things that we did when we had transformations. So the same transformation rules applied. So I just picked up these 3 from before. So these are these 4. I can't count today. So the transformation rules. Remember, if it's inside with x, it moves left and right. And it's opposite what we think. So this means that it moves right C, and this means it moves left C. And if it's outside, then it means it moves up and down, and it moves the same direction. So this is down D and up D. So what would this look like in terms of our logarithm functions? Well, in terms of our logarithm function, it would be log of x minus c, log of x plus c, log of x minus d, log of x plus d. So this is kind of what this would look like as far as our logarithm. So in this function, the logarithm of x plus 4, this is going to be, it's inside with x. So this means that it's going to move left 4. Now, remember our graph crosses, so we're going to think about this point right here. It crosses at 1, 0. So that's the point we're going to shift, okay? So we're going to shift that 1, 0 left 4. So 1, 2, 3, 4. And then it goes up against and then up. So that would be left 4. So What does this one do? Well, this one's outside of the x because there's no parentheses. So this one would be down 3. So if this was our original point, we would now move 1, 2, down 3. And we would go up against x. And here would be our graph. And let's say this one here, this is plus 5 outside, so this would be up 5. So if this was our original graph, 1, 2, 3, 4, 5, up against x, and up 5, okay? So what would this graph do? Well, it moves in 2 directions. So this part moves up 2, and this part moves right 4. So from this point, we're going up 2 and 1, 2, 3, right 4. Now remember, the graph goes right up against the line beside it. So it's going to go right up the line beside it and then there. So this graph would go down 3 and this one would go left 1. So we start from here. We go down 3, 1, 2, 3, and left 1. It will go right up against the graph beside it, the line beside it. And that's what those graphs would look like. So that's all you would do for a logarithm graph. Just shift it. Now, if it has negative, and remember, you can plug these in your calculator. You can plug these in y equals in Desmos. Well, you wouldn't even need y equals in Desmos. You would just, in your calculator, you would plug these in y equals. In Desmos, you would just plug it in. So we could do log base 5. So let's graph this. If we wanted to see what this graph looked like, we would say log A, so log base 5 of, let's do this bottom one here. What was the equation? X plus 1 minus 3. So we would do x plus 1 and then outside minus 3. And so you see that our point went at 1, 2, 3 here, right? And so Desmos put that point at 1, 2, 3, and then it swooped over. So you can graph it in Desmos as well, okay? So you can get an idea of what it looks like as well. So whether you're graphing in Desmos to look at the shift or you're using your shift rules, either way works. And that's all you need to do in order to graph logarithmic functions. Use your shift rules